Good day, everyone. I am Ronela Doquila, a BSA student of North Pamplona campus. Today, me and my partner Angelian will explain our answer in Organic Chemistry Ag 104, Lesson 2, Structure and Bonding. Okay, let's start. Problem number 1.1. How many electrons does each of the following elements have in its outermost electron shell? A. Potassium. Electron shell of potassium. Potassium has 1 electron in its outermost shell. Electronic configuration of potassium. 1 has 2 electrons, 2s has 2 electrons, 2p has 6 electrons, 3s has 2 electrons, 3p has 6 electrons, and 4s is 1 electron. Letter B. Calcium. Electron shell of calcium. Calcium has 2 electrons in its outermost shell. Electron configuration of calcium. 1s has 2 electrons, 2s has 2 electrons, 2p has 6 electrons, 3s has 2 electrons, 3p has 6 electrons, 4s has 2 electrons. C. Aluminum. Electron shell of aluminum. Aluminum has 3 electrons in its outermost shell. Electron configuration of calcium. 1s has 2 electrons, 2s has 2 electrons, 2p has 6 electrons, 3s has 2 electrons, and 3p has 1 electron. Problem number 1.2. Give the ground state of electrons configuration of the following elements. A. Boron. Ground state electrons configuration. 1s has 2 electrons, 2s has 2 electrons, 2p is 1 electron. Configuration. Letter B. Phosphorus. Ground state electrons configuration. 1s has 2 electrons, 2s has 2 electrons, 2p has 6 electrons, 3s has 2 electrons, and 3p has 3 electrons. C. Oxygen. Ground state electrons configuration. 1s has 2 electrons, 2s has 2 electrons, and 2p has 4 electrons. Problem number 1.6. Write both electron dot and line bond structures for the following molecules showing all non-bonded electrons. Cl3, chloroform. These are the electron dot, and this one is the line bond. Okay. B. H2S, hydrogen sulfide, and this is the line bond, and this is the line band also. Okay. C. CH3 and NH2 methylamine. This is the electron dot, and this is the line bond. Okay. Now, my partner will explain the remaining problems. Angelian?
Good day, everyone. I am Angelian Nicole Ontolan, Miss Ronela's partner, and I will explain our answers of the remaining problems. Problem 1.7. Why can't an organic molecule have the formula C2H7? The formula cannot be used in an organic molecule because it would require a C atom to have more than 4 bonds or an H atom to have more than 1 bond. Covalent bonds are formed between organic molecules, such as those that solely contain the atoms C and H. How many electrons an atom requires to achieve a noble gas configuration determines how many bonds it can form. Due to the fact that C and H valence shells can only hold 8 and 2 electrons respectively, they cannot have more bonds than this. Formation of the given molecule, 2 C atoms and 7 H atoms cannot be arranged using the guidelines. Here are some representations of C2H7 that are all illogical. The underlined atoms indicate that their valence numbers are excessive. More bonds than permitted are formed by the atoms in the illustration. The formula cannot constitute an organic molecule since it would require either a C atom with more than 4 bonds or an H atom with more than 1 bond. Problem 1.16. Which element in each of the following pairs is more electronegative? A. Li or H? Here in our table, you can see here the H and Li. Now, we will find their electronegative value, which is here, this one. H electronegativity value is 2.20 and Li electronegativity value is 0.98. Comparing these two elements, we can already see that H is more electronegative than Li because of its bigger value. Therefore, our answer in letter A is H. Letter B, Be or Br. In our table again, we have here Be and Br. Br's electronegativity value is 2.96 and Be's electronegativity value is 1.57. Again, comparing the two elements, we can see that Br is more electronegative than Be. You can see here that Br have a greater value than Be. Therefore, our answer is Br. Letter C, Cl or I. We have here Cl and I. Cl's electronegativity value is 3.16 and I's electronegativity value is 2.66. Comparing these two elements, we can already see that Cl is more electronegative than I because Cl's electronegativity is more greater than I. Therefore, our answer is Cl. Problem 1.17. Use the partially positive or partially negative convention to indicate the direction of expected polarity for each of the bonds shown. Letter A, C, and Br. We have here C, and C's electronegativity value is 2.55, and Br's electronegativity is 2.96. Comparing the two elements, we can see that Br is more electronegative than C. So, it means that C is partially positive and Br is partially negative. Letter B, C and N. C's electronegativity value is 2.55 and N's electronegativity value is 3.04. Comparing the two elements, we can see that N is more electronegative than C, right? Because C have only 2.55 and N have 3.4. It means that C is partially positive and N is partially negative. Letter C, N and H. Our table we have here N and we have here H. H electronegativity is 2.20 and N's electronegativity is 3.4. You can see that N is more electronegative because it have a value of 3.04 and H is lesser because it only have 2.20. It means again that nitrogen is partially negative and H is partially positive. Letter D, C and S. C and S. C have a electronegativity value of 2.55 and S have a value of 2.58. Comparing the two elements, we can already see that S is more electronegative than C because it have a value of 2.55 and C only have the value of 2.55. Therefore, our answer is C is partially positive and S is partially negative. C and Mg. We have here C, which have a electronegativity of 2.55 and Mg with a value of 1.31. Comparing the two elements, C is more greater or more electronegative than Mg, right? So, therefore, our answer is C is partially negative, Mg is partially positive. F. C and F. We have here C with an electronegativity of 2.55 and F with electronegativity of 3.98. Comparing these two elements, we can see here that F is more electronegative than C because F have a value of 3.98 and C have the value of 2.55, right? So, our answer is C is partially positive and F is partially negative. We find the answer by remembering or by taking notes that if an element is less electronegative, then that element is partially positive. And if that element is more electronegative, then that element is partially negative. Problem 1.18. Order the bonds in the following compounds according to their increasing ionic character. CCl4, MgCl2, Cl3, and Cl2O. We, uh, we have to find the difference of the two elements. First, we will find the electronegativity value of the elements. Chlorine's electronegativity is 3.16 and carbon's electronegativity is 2.55. Their difference is 0.61. Next, chlorine's electronegativity is 3.16 and magnesium's electronegativity is 1.31. Their difference is 1.85. Next, chlorine. Chlorine's electronegativity is 3.16 and titanium's electronegativity is 1.54. Their difference is 1.62. Oxygen's electronegativity is 3.44 and chlorine's electronegativity is 3.16. Their difference is 0.28. And we have here, inside the box, the compilations of the answers. CCl4, which have a 0.61, MgCl2, 1.85, TiCl3 with a 1.62, and Cl2O, 0.28. Now we will have just order these four to an increasing order. So here, we have here the answer. Therefore, the increasing order of the bonds in the following compounds according to their ionic character: Cl2O, CCl4, TiCl3, and MgCl2. Thank you everyone for watching our video explaining our answers in AG 104, Lesson 2.
Thank you, everyone, for watching our video explaining our answer in AG 104, Lesson 2.